before we can talk about how to find the angles inside of polygons, we need to do some quick vocabulary. The angles that occur in the interior of the polygon, we're going to call the interior angles. Yes, I know. It's crazy, right? What do you think we're going to call the ones on the outside? Exterior angles. Any guesses on what you think the relationship between the interior and the exterior angle would be? What do you think the relationship between the interior and the exterior angles would be? No. You're thinking. They add up to 180. What do we call that? Supplementary. Okay, so they form a linear pair. So your interior and your exterior angles are a linear pair, and they would be supplementary of each other, meaning they would add up to 180 degrees. Okay, so here is our formula. Before we get there, I'm going to do a quick activity up here. Not activity. I'm just going to see if you guys can figure this out. Just watch. Don't write anything. How many degrees do we know are inside of a triangle? 180 degrees. Good. So now, if I make a quadrilateral, specifically a rectangle, and I put one diagonal in it, how many triangles do we now have? Two. So what will be the sum of the angles inside that? Yeah, because in here I have 180, here I have 180, so together I would have 360 degrees. Now I'm going to do a five-sided shape. What do we call that? Pentagon. If I put in the diagonals there, I now have two diagonals. How many triangles? And each of those I have how many degrees? 540. So 180 times 3 would be total 540. Six-sided shape, what do we call that? Good. How many diagonals do you think we would have? Well, I've had one diagonal, two diagonals, now we're at not four, three diagonals for triangles, right? So how many degrees do we have inside there? Is that what it is? No. Add 180 to 540. 720, right? Yeah. Okay. Next, what do we call a seven-sided figure? 4, 5. Yeah, septagon. So we would have how many triangles? So we've got 5. So 180, 180, 180, 180, 180. How many do we have inside total? 900? All right, so does anybody see a pattern? Here I had how many sides in my triangle? 3. And I had how many triangles inside? 1. Here I had 4 sides, and I had how many triangles? So here I had 1 triangle. Here I had 2 triangles. Here I had 5 sides and had how many triangles? 3 triangles. Here I had 6 sides and had 4 triangles. Here I had 7 sides and had 5 triangles. Does anybody see a relationship between the number of sides and the number of triangles? That's a pattern. What's the pattern? You're subtracting 2 each time, right? So you're taking your number of sides and subtracting it by 2. Then what are we doing to get to this final degree?
Adding all the triangles together.
Which would be the same as multiplying by 180, right? Wouldn't it be adding 2 180s the same as multiplying by 2? Or adding 100 or 3 180s would be the same thing as taking 3 times 180. So we're taking our number of triangles, multiplying by 180. To get our number of triangles, we're taking our number of sides and subtracting 2. So our formula to find the sum of the interior angles is n minus 2 times 180, where n equals the number of sides. Again, you might want to put a little star next to this box and say, put this on my index card. So when you are studying and prepping for this quiz on Friday, and you're working on making your index card, you're looking back at your notes and you're saying, oh, Mrs. Crowley suggested I should put this on my index card. Okay? So, using that formula, we should be able to find the sum of the interior angles of any side polygon. So, for our first example, find the sum of the interior angles of a 14gon. So, what are we going to do? We're going to do 14 minus 2, and then we're going to multiply that by 180. So 14 minus 2 is 12 times 180. I don't have that number in my head. I'm going to need a calculator to help me out with that, unless someone's got it. 12 times 180 is 2,160 degrees. Okay. So for example number 2, now we're going to work a little bit backwards. The sum of a polygon's interior angles is 4,320. How many sides does it have? What do you think we need to do? We need to work backwards. Divide by 180 and then add 2, right? Because first we subtracted 2, then multiplied by 180. Now we're going to do the reverse of that. Algebraically, if you want to see it, remember our formula is n minus 2 times 180 equals our sum, which in this case is 4,320. So if I wanted to solve that equation for n, we could divide out the 180. So that gets me, what, 432 divided by 18. So n minus 2 equals 24. And then my next step would be to add 2. So that means that my shape would have 26 sides. 26gon. I'm sure it has a fancy name. I don't know what that name is. So we would just say 26gon and be lazy about it. Okay? So that gets us the sum of all of the angles. If I wanted to find just the individual angle, what would I then do to that sum? If this was the sum of a 26-sided figure, and let's say that it's regular, meaning all the sides are the same, all the angles are the same, how could I get just an individual angle? So if I had 26 sides, that means I have how many angles? 26 angles. And if all 26 of them add up to 4,320, and all 26 of them are the same, what would I do to that 4,320? Divide by 26, right? So if I was looking for just an individual interior angle, and this only works for regular convex polygons, meaning all the angles are going to be the same, we take our sum formula, which is that n minus 2 times 180, but then we just end up dividing by n. Because then that would get me just one of the angle degrees instead of all of them together. Jackson?
When we're writing these on our note cards, can we write like some of the interior angles of
Yep.
that convex?
Yep. Okay. All right, so if we do the last example on the front here, we want to know what is the individual interior angle measure of a regular decagon. Well, decagon has how many sides? So n is going to be equal to 10. I am asked for an individual interior angle. So first I need to find what the sum of all 10 would be, and in order to do that I'm going to do n minus 2, so 10 minus 2 times 180. That gets me the sum of all 10, but I want just an individual one, so then I would divide whatever that number is by 10. Yeah, so 8 times 180 is 1440, divided by 10. Gets me a final degree of 144 degrees. So that means in a decagon, if it was a regular decagon, each individual angle would be 144 degrees. Okay? So, interior. The beauty of exterior is it's a lot easier. Are you ready for exterior angles? So, flip on to the back. Your exterior angles, no matter the shape, no matter the number of sides, will always add up to 360 degrees. It's crazy, but it does. So it doesn't matter how many sides your shape has, the sum of your exterior angles will be 360 degrees. And that's going to be one of those trick questions that some of you guys are going to get wrong. I'll say, what is the sum of the exterior angles of a 101 gon? And then you'll start doing some math when all you needed to do is just put 360. Okay? No math needed. So, find the sum of the exterior angles of a convex 20 gon. 360. It is. It's so easy that people will get it wrong because it is that easy. It's one of those types of problems. It's so easy that you'll get it wrong anyways. So find the sum of the exterior angles of a 101 gon. 360.
No wait, it's 360.
All right, so then what do you think we're going to do to find the individual exterior angle? If all of them add up to 360, we would take 360 and divide it by the number of sides. So 360 divided by n. So find the individual measure of an exterior angle of a regular dodecagon. How many sides does dodeca have? Well, deca is 10, so dodeca would be 12. Good. So dodecagon means we have 12. So the individual measure of an exterior. So I see the exterior, so right away I'm thinking it's 360, but I want the individual. So I'm going to do 360 divided by 12, which gets us, what, 30? So we've got 30 sides. Or not 30 sides, what am I talking about? 30 degrees. So find the individual measure of an exterior angle of a regular dodecagon. 30 degrees. All right, so now we're going to take interior, exterior, and we're going to add some algebra into the mix with some diagrams. So this is where it gets a little bit tougher. So first example here, do we have interior or exterior angles? Interior, okay. How many sides do we have? 4. So to find the sum of those angles, we're going to do 4 minus 2 times 180. And I know this is a bit redundant because you guys probably already know it's 360 degrees because it's quadrilateral. But I want to do this because it's not always going to be 360 for interior. And that's where a lot of students will make mistakes. Is they'll see interior angles and they'll just do 360 because they like the number 360. So 4 minus 2 is 2. 2 times 180 means it's 360 degrees. Thank you. So the sum of all 4 of those angles should add up to 360 degrees. So x plus 59 plus 121 plus 108 equals 360. When we add up those degrees, 59 plus 121 plus 108 is 288. So x plus 288 equals 360. Subtract that from 360 gets me x is equal to 72. Okay. Again, your interior is not always going to be 360. That's going to change each time depending on how many sides it has. So you have to do your n minus 2 times 180 whenever you see interior angles. All right, and number 2, we have exterior angles. So the sum of the exterior angles is always going to be what? 360. So if you have exterior angles, then yes, you will always equal them to 360. So we're going to do a 2x plus a 1x plus 67 plus 89 and equal that to 360. Yep, I would combine like terms. I would get 3x plus 156 equals 360. 360 minus 156 is 204. Divide by 3 gets me 68. So x is equal to 68. Okay? So exterior sums will always, 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 always be 360. Your interior may not, depending on how many sides it has. So you have to remember whenever it's an interior example, you have to do n minus 2 times 180 first before you set that equal to it. Okay?